Hi, I'm William reporting for the Fun Robotics Network. I'm here with Team 17556 VegeMight. They have an awesome claw with multiple degrees of freedom. Learn about their different wire protection systems, all on Behind the Butt. So when approaching the start of the season, what was your initial plan?
Hi, so we did a couple initial sketches trying to understand and kind of brainstorm what was best, but we had to talk with a lot of more experienced members to get a better idea. One of our major philosophies was consistency through simplicity, because we know that even if you have a really large bot, you have many points of failures, and then it might work really good at school or at home or whatever field you're using. When you get to comp, one thing breaks and you're done for. So we opted for a no transfer design, and this is partly influenced because we are an almost fully rookie team. So we're very happy to be at nationals because of that. But so our robot simply picks up like this, so goes up, and then it can deposit easily. So a no transfer stage means we actually are very capable of picking things up consistently. Our bot never breaks during matches, and we're very happy with that.
Would you like to show and to demonstrate and explain how your overall arm system works?
Yes, sure. So Caleb here is going to show us how the robot turns on. All of this is custom cut 3mm aluminium. And then if you just show us how it would go down to pick up a sample. So here we have a counter-sprung arm with these elastic bands. This is because the inertia from it to go down, so pretend you're going to go down to pick up a sample. So right here, when it tries to go back up, the inertia is very difficult, and usually the acceleration would be a lot slower than what you just saw. So here the counter-springing helps the arm to go back up that much faster. We opted for the perfect length to still be safely inside the 18-inch sizing tool, but be as high as we could to ensure that we were, scoring those high baskets without catching on anything.
So I see that you have multiple degrees of freedom, especially on the end of your arm. Would you like to explain and showcase all of that off as well?
Sure, Caleb.
So our arm has a junction here which is connected to an axon, which allows the robot to move the claw. We opted for a bracket here to make sure that it doesn't fall off when we're hanging specimens, and instead of being connected to the robot with one point of contact, it's more structurally secure.
And we also opted for this type of junction here because having 3 bevel gears takes up too much space, and for us this is like the weakest point for like the motors, and it's most likely to fall off or be too heavy, so that's why we opted for like a simple junction here. However, we made it more secure by putting brackets around it, and that again is the same thing we did for the axon here. So now the weight of the servo is now part of the junction compared to if it was on top, below, or on the side.
So I see that your arm is connected to the SAR 3s instead of SAR 2s. So why did you choose to do that one?
Well, we do know that it's a little bit harder to string up, but for us it was important to maximize the maximum height that we could reach, and we also wanted to maximize the amount of space that we had in between here. And that's because we wanted to fit in these servo blocks here. We're having some issues at regionals where connecting this arm directly onto the Axon Maxes made the arm wobble a bit, and we were worried about the longevity of these servos. So these Axon Maxes now, which we only had because of the space of these R3s, allows us to ensure that stability. Then if you have a look at our slide inserts here, for how we actually strung it up, these are custom made. So after the recommendation of one of our more experienced teams, we like consulting them because, like I said, we are a rookie team. So we found out that actually putting these nice little V-grooves above the slides ensures that we reach max extension each time. In the past, we were having issues where it was very dependent on our battery level. So if our battery wasn't high enough and we were doing something else at the same time, it wouldn't reach the top. Now it always reaches the top because of where the string is.
So I see that your overall chassis is shorter in the base. Is that so that you can try and reach more into that submersible zone?
Yes, definitely. We wanted to maximize the amount of space that we had, because that way we wanted to be able to go as far deep into the basket as possible. So that way, when we drop it, there's more chance that it actually falls into the basket. We're not being a bit close. It also ensures that we have more of an extension limit. for our overall extension, as we'll show you shortly.
So I also see on the robot that you have a way to prevent samples from getting stuck in it. Was that how did you come across that?
So during regionals in our final match, what happened was, unfortunately, because of the jittering at the venue, we put a base plate here, and this was made of acrylic as well, so it's really easy to slide off. And so what that just means that if a sample comes down, it'll just simply slide off. And if it was to get into any of these small nicks and areas, we could just spin it off or like bump the robot against the plate. Now, to make it more accessible and also for us to access the wiring underneath and the motors for the lift, we decided to do Velcro on the sides and made a clip that goes onto the side plates here.
So you're moving on from your robot. Would you like to talk about any of the software features that you have?
So we opted for FTC lib because we've had some experience with it in the past, and it ensures that all of our subsystems work together without any potential conflicts. We pretty much created one subsystem for every part in here. So our lift is one, our wrist is one, and all of that works together very nicely. We have about 30 different commands, all to control different aspects. Some of them are manual control, but it's really to help our driver just click one button and have something automatic happen.
And I have one final question: is what would you? So I know that you said you were going to go to APOC. What are some of the improvements that you want to make for it when preparing for that next year?
I think for next year, we would really love to implement CV onto our robot to make it able to more rotate the claw to pick up the samples better inside the submersible. In addition, we might think about improving the material the robot made of, so maybe implementing carbon fiber, possibly.
And also, I think what we're going to do is that we're going to change the side plates to something lighter and maybe update our drivetrain as well for those rubber type of chains, and possibly change these motors, because right now they're on 312 RPM motors and we might change them to 1150. So there's a bottom drivetrain here. We decided to put these on the inside just to save space, and all our wiring goes through this little cut channel, that little cut plate in there that goes directly to the control hub. And we also have autopods here.
Thank you so much for sharing your robots. And why the color yellow?
That's a very good question. You see, our team is called VegeMight, and so we wanted to brand our robot to be just like us. We're very big on team spirit. We have this massive mascot that people can actually go in. So we have our mascot, we have our signs, we have everything, and then now this bot is a perfect representation of the team. Yellow and red everywhere. We love being on the red lines for that reason. Caleb, would you be happy to show our parking, the ultimate reveal? And boom, that is our park. It's completely decorative, but we needed the extension space for the flag to showcase our team spirit and kind of show everyone how much we love VegeMight. Thank you.
Thank you very much for sharing. This has been Team 17556, VegeMight.